Hello everyone, myself Ami Mehta, and in operating system let us discuss what is DMA, which is direct memory access. So direct memory access is basically the feature of computer system that allow certain hardware subsystem to access main memory independent of the central processing unit. So basically what happened in first scenario that whenever you want to access the main memory, each and every time the CPU is involved. So CPU is utilized maximum their time in operation of main memory. So now what happened in direct memory access, that this is the feature that allow the computer system that certain hardware subsystem that can access main memory without interference of CPU. So for example, in first scenario, what happened that if there is a CPU and they is utilize their maximum time in allowing access memory and transfer of data, then the main task of CPU will not happen. So now what happened in this, that without DMA, when the CPU is using programmed input output, it is typically fully occupied for the entire duration of the read or write operation and is thus unavailable to perform other work. So basically the first of all CPU is using program input output and it is fully occupied for the entire duration of the read or write operation. With DMA, the CPU first initiate the transfer, then it does other operation while the transfer is in progress, and it finally receives an interrupt from the DMA controller when the operation is done. Which means now CPU is hand over there some task to DMA. So first it assigns some tasks to DMA. When it completes, DMA recall it back that this particular task is completed. So the CPU first initiate the transfer, then it does other operation while the transfer is in progress, and it finally receives an interrupt. So DMA send an interrupt to the CPU that this task is completed. So the particular operation is done. So this operation is nothing but the read or write operation from the memory. So something want to write into memory and something want to read from the memory. So this feature is useful when the CPU needs to perform useful work while waiting for a relatively slow IO data transfer. Okay, so this is the concept of why direct memory access is required, and from this concept how we can utilize maximum time of CPU. Now how this operation is performed without DMA. So this is the CPU, this is the disk controller, this is the main memory. So every time whenever there is a requirement of transferring data between main memory, CPU is occupied. For example, from drive data is come into this buffer, from buffer now there is a requirement of read or write operation with main memory, CPU is occupied. Let us understand this controller reads the block from the drive serially bit by bit until the entire block is in the controller's buffer. So this is the disk controller. So this is the disk controller which read the data from drive byte by byte. Whenever this IO operation is performed, the byte by byte data is transferred into this disk controller buffer. Now what happened? Next, it computes the checksum to verify that no read errors have occurred. Then the controller causes an interrupt so that operating system can read the block from controller's buffer by executing a loop. After reading every single part of the block from the controller device register, the operating system will store them into the main memory. Now what happens? There is this controller check if there is a read error or not. If there is not, this controller send an interrupt to CPU. Now CPU read this data from this buffer byte by byte to the main memory. So CPU is occupied by all the time. So this is the concept where there is no direct memory access concept. So now what happened while we are using DMA? So first, what happened that first the CPU programs the DMA controller by setting its registers so it knows what to transfer where. So basically DMA is actually programmed by CPU, but CPU is hand over there some task to DMA. So firstly, CPU programs the DMA controller that what its register have to where to transfer, and it also issue a command to disk controller telling it to read data from disk into its internal buffer and verify the checksum. So the first task that is handled by the CPU is CPU programs the DMA controller. Whenever the CPU completes it's programmed to DMA controller, the next task that this data in this controller buffer is transferred from the drive. Now what is the second step? DMA controller initiate the transfer by issuing a read request over the bus to the disk controller. Now DMA request to transfer memory. So now first CPU transfer to main memory from this disk controller buffer to main memory. Now there is a concept of DMA, so there is a no this line to transfer. But what happened? This is via what happened? This is via DMA controller. So now this is removed, and from DMA controller it access the transfer from disk controller buffer to main memory. So this read request looks like any other read request, and this controller does not know or care whether it came from the CPU or from a DMA controller. So it will allow basically this controller buffer to read the data and transfer it into main memory. So typically the memory address to write to is on the bus address lines. So when the disk controller fetches the next word from its internal buffer, it knows where to write it. So basically now this controller's buffer data transfer to main memory via DMA controller. Okay, so this is the concept of how actually DMA will work. The next step is when the write is complete, the disk controller sends an acknowledgement signal to DMA controller also over the bus. So it is send the acknowledgement via bus. DMA controller then increments the memory address to use and decrements the byte count. So, if the byte count is still greater than 0, steps 2 to 4 are repeated until it reaches 0. So, this process is continue until all read operation will not completed. So, at the time the DMA controller interrupts the CPU to let it know that the transfer is now complete. When the operating system starts up, it does not have to copy the disk block to memory, it is already there. So the work of CPU is now divided by DMA controller. Okay, so this is the concept of how actually direct memory access will work. Now let us discuss what is operating system design issues. So what is the design objective? So two objectives are paramount in designing the I/O facility. So the first one is efficiency. So efficiency is important because I/O operation often form a bottleneck in a computing system. Most I/O devices are extremely slow compared with main memory and the processor. The second one is generality. So it is desirable to handle all devices in a uniform manner. Applies to the way processes view IO devices and the way the operating system manages IO devices and operations. So because of the diversity of device characteristic, it is difficult in practice to achieve true generality. What can be done is to use a hierarchical modular approach to the design of the IO function. This approach hides most of the details of device IO in lower level routines so that user processes and upper levels of the OSC devices in terms of general functions such as read, write, open, close, lock and unlock. So basically, user cannot know the detail of the uh, inner level of the operating system, but it only see in terms of the general functions such as read, write, open, close, lock and unlock. So this is all about how DMA will work. DMA is working in operating system and what are the design issue of the operating system. Okay, thank you.